Hi there, welcome to another video for Cert Ordinary Level Maths, continuing with Arithmetic and now looking at percentage error. So when things are being measured in that, sometimes errors will occur, and it's important that you're able to identify, how far out am I? What's the error in my measurement or my estimation? So when taking measurements, errors can occur. The error is the difference between the true value and the measured value. So if I measure it, it mightn't actually be the correct true value. Relative error, is basically just the error over the true value. So you find out how much you were out by and you put it over the true actual value. That's called your relative error. And then your percentage error is you just take that relative error and you multiply it by 100 to turn it into a percentage. The value of the error is always taken as a positive value. So whether you were above it by 10 or you were below it by 10, you'll just say that the error was 10. You were out by 10. In this example, to calculate the value of 121 plus 46 plus 37 plus 26, Harry made a rough estimate of the answer by rounding each number to the nearest 10 and adding the results. Calculate his percentage error. Okay, so here Harry is taking an estimate of each one, which means he has an error for the first number, an error for the second number, error for the third number. And we call that the accumulated error. So when you're combining the inaccuracy of multiple errors, you add them together, that's your accumulated error. So you can treat it as just one error. You don't have to do out a different one for each number. So let's add up what the true value should have been. So if we added up 121 and 46, 37 and 26, you add them all up and you get 230. Now Harry estimated it to the nearest 10. So he would have added 120 and 50 and 40 and 30, and when he added them all up he got 240. So we can see that his error is the difference between these two numbers, so his error is going to be 10, and we want to find his percentage error. So we take the error and we put it over the true value, so what it was when you added up all the proper numbers, which was 230, and turn that into a percentage. You multiply it by 100 over 1, which comes out as 4.3478%. And depending on the question, then you go back and read it, they might ask for certain amount of decimal places. Let's say they asked for the 2 decimal places. So it'd be 4.35% is how much he was out by. That was his error. Quickly then just talk about tolerance as well. So tolerance is where, you're allowed to be out by a bit. Any measurement made is an approximation. So e.g. your ruler is as accurate to the nearest millimeter. So it can't measure less than 1 millimeter on your ruler. And even if you're using like an electron microscope, there's going to be some kind of tolerance or inaccuracy there. No matter how accurate it is, there's going to be just a tiny little bit out. To determine the tolerance in a measurement, so how much it's going to be out by, add and subtract 1/2 of the precision of the measuring instrument. So if you're measuring a line with your ruler and you get a result of 10.5 centimeters, the ruler is as accurate to the nearest millimeter, so 0.1 centimeters. So the tolerance for that measurement is going to be 0.5 centimeters plus 0.05 centimeters. So like 1/2 millimeter above it and 1/2 millimeter below it. That's your tolerance. You're like, okay, well, this is what my ruler said, but because it's only as accurate to the nearest millimeter, it could be 1/2 millimeter longer than the line that I measured, or it could be 1/2 millimeter smaller than the line that I measured. And that's called the tolerance that you can be within. Okay, that's taking percentage error and tolerance. I hope you found that useful.